be. And welcome to this AWS 201 webinar. My name is Markku Lepistö. I'm a technology evangelist for Amazon Web Services working out of Singapore. Today's webinar is on Amazon Virtual Private Cloud, or VPC. And it's a 200-level webinar, so it assumes that you have a basic knowledge of cloud computing and Amazon Web Services. In addition to that, in this session we will be covering a lot of networking related topics, so it's good if you have a certain background in IP networking technologies, firewalls, routing and switching, etc. Still, I will make my best to make this webinar easily understandable for everyone. So without any further ado, let's get going. Let's start with a couple of housekeeping items. I will be running a presentation, roughly 40 minutes or so, give or take. And while I'm presenting, please take advantage of the chat system and post your questions online. Some of my AWS colleagues are online with us, and they will be answering as many of the questions as possible online as I'm presenting. And at the end of the presentation and webinar, we can still continue the Q&A for a while using the online chat system. And then a reminder, please fill in the survey. AWS and Amazon is a customer-obsessed company. We really love your feedback, and your feedback lets us know what we are doing well, where we can improve, and how we can iterate to make our services better. So please fill in the survey. Okay, now let's start today's show on VPC. Let's start by talking about hybrid IT. What exactly is hybrid IT? Well, here's one definition from Gartner, and I've highlighted a couple of interesting points here. So hybrid IT has something to do with services that are being delivered out of internal or public cloud systems in support of business outcomes. So basically, you have services. At Amazon Web Services, we have services building blocks, but at the end of the day, you want to deliver outcomes for your business. So basically, what you can do is that you can use the services building blocks to build solutions and then to deliver these solutions to your internal or external customers for your business benefits. So now that is a really high-level view. What are these service building blocks then? Well, on really high level, at Amazon Web Services, this is our platform. At the core of the offering, we have the basic building blocks of all of IT. You have the compute, storage, database, and networking services. And we surround these with application services such as message queues, notifications, etc., deployment, application lifecycle management, identity and access management, administration, etc. services. And we deliver these services out of our global infrastructure, which as of today consists of 10 geographical regions and multiple availability zones. Now, the Amazon VPC, or Virtual Private Cloud, is not necessarily only for hybrid IT, but it's quite often used for hybrid IT. So let's take a look at what is the focus of AWS hybrid IT. On the left, you have your data centers or offices. Hang on a bit. Okay, sorry, let's continue. It seems that there was a small hiccup in the system. Lucky we didn't get too far. I hope that you can see the slides correctly now. So let me backtrack just a little bit here. So here we have the Gartner definition, services to deliver business outcomes. I'm just backtracking a little bit so that you can see what I was showing. You have services. You have sets of services to deliver business outcomes, but basically use the service building blocks to build solutions to deliver your business outcomes, hopefully positive outcomes. And this was the picture that I was showing, where the AWS platform has compute, storage, and database services in the middle, and networking services to interconnect them, application middleware services on the top, application lifecycle deployment on the very top, delivered through our global infrastructure. And now we caught up where we were. I hope everybody can see the screen nicely now. So the hybrid focus is as follows. you have your data centers and offices on the left with your on-premises applications and systems. And on the right, you have the AWS cloud. Now, in order to have hybrid IT, you will need private systems in the cloud that are secure and isolated from other tenants. You will want to have private connections. You need to be able to migrate your workloads and your data back and forth between the two systems. You will need to have good access control, and ultimately you would want everything to work with your existing management tools and processes as much as possible. So in order to make this easier, we are providing tools to support your hybrid IT architectures. So you will probably have a corporate directory where you have the usernames and passwords of your existing users. Using IAM, or Identity and Access Management services of AWS, you can easily integrate the cloud accounts of your user to your existing, for example, Active Directory user base in your on-premises system. You will have servers in your existing data centers most likely. So what you can do is that you can image your existing servers, whether they are physical or virtualized, and then import them into AWS and run them as cloud workloads on EC2. You will definitely need to interconnect your existing networking systems in your data centers and offices to the cloud networks that you manage yourself on top of AWS. And this is exactly the point of VPC, and more about that shortly. You will want to use these networking connections to expand, for example, not just your compute, but of course also your storage system's capacity into the elastic on-demand capacity of the cloud. And ultimately, you can then enjoy having hybrid applications where maybe a part of the application is still running on-premises, and you can expand the capacity of your application into the cloud using the secure VPC connections. Now, how does this all work? Let's take a look at Amazon VPC. So with Amazon VPC, you can extend your data center to the AWS cloud. With VPC, you can create logically isolated sections of the AWS cloud using your own network addressing. So you can define the network addresses and subnets. You have complete control over the virtual networking environment. So you can create subnets, you can create IP addresses, you have full control of the routing tables and all kind of network gateways that I will be showing to you later. So basically, for example, here in the picture, you can create one subnet in availability zone A in your VPC and another subnet with your own IP addresses in the second availability zone. You can have full control of the routing rules, how you can route traffic between your VPC subnets and other subnets. You can have virtual private gateways to connect to the VPC from your on-premises system. You can have internet gateways to connect to the internet from your VPC or to your resources in your VPC from the internet side. But of course, you have full control over who is able to connect where and from what. You can also have NAT instances, and more about that later. Definitely, you need to be able to create private or public subnets. So some of the subnets you create will be public-facing with your external systems, but some of the subnets will be hosting internally facing systems that are not meant to be seen or accessed by external users. And then, of course, you have full control over where you deploy your EC2 instances or other AWS resources like Redshift data warehouses or RDS databases, for example. Once you have multiple subnets in your VPC, you can use NACLs, or Network Access Control Lists, to have stateless firewalls controlling which subnets can send which traffic to which other subnets. So NACLs give you stateless firewalls between subnets in the VPC. In addition to the NACLs, which are stateless firewalls, you can have stateful firewalls protecting your instances. So these are the familiar security groups. If you have used EC2 Classic, you may be familiar with the security group concept, which is a sort of a firewall protecting your instances or groups of instances. Now in VPC, the security groups have more features. For example, you can control also egress or outgoing traffic, so both incoming and outgoing traffic to and from your instances. And they are stateful firewalls that you can control on instance level. Now that's all good. You have created a VPC. How do you connect to it? Well, let's say that on the bottom here, you have your corporate network, your on-premises system. On the top, you have your VPC that you have created in the AWS cloud. You have two ways, or multiple ways, but two common ways of connecting to your VPC. The first one that people tend to use first is an IPsec VPN connection. So here, you will create IPsec VPN connections or tunnels over the public internet from your on-premises system to the VPC on the Amazon side. So you will secure the connection over the internet using IPsec VPN standard connections. In order to do this, you will need to have a router or firewall that is IPsec compatible. For customers who use VPC for heavy processing, heavy traffic, maybe mission-critical production systems, they quite often opt to use what is called Direct Connect. So with AWS Direct Connect, you can provision your own connections to the AWS cloud. You can specify from the services providers different connection speeds, for example, from 50 megabits per second up to 10 gigabits per second. You can have multiple connections that are routed in through different routes for redundancy. You can load balance these connections, you can aggregate them, you can use them as active standby connections. And you can use these in conjunction. You can use both of them. So the best practice really for mission-critical systems is to have redundant direct connect connections from your on-premises data centers to your VPC and a backup connection over the internet using IPsec VPN. Now, let's start our demos. And these are live demos, so anything can happen, but let's see how it goes. In the first step of our demo, we will be creating a new VPC in Singapore. So let's take a look. What are we going to build? Our first virtual private cloud will look like this. We have our office. Today we have our office in Tokyo, Japan. So in Tokyo, we have a Windows workstation and we have an office network. So I know there are many numbers here, but try to remember these. Our office network is 10.96.24. So 10.96.24 is the subnet of our office network. We have a VPN gateway. We have a Cisco router that's capable of IPsec VPN connections. Using that, we will be connecting to a VPC. So we will be creating our own virtual private cloud in the AWS Singapore region. So in Singapore, we will create one private VPC, which we will only use to expand capacity of our on-premises system into the cloud. So we will make a completely isolated and private VPC in Singapore. Within the VPC, we will be creating two subnets, one in availability zone A and the other one in availability zone B. And you can see the network addresses here. So we will be creating the subnets in the class 10.100.0.0.16. So we will create a B-class network in the VPC and then two subnets with roughly 512 addresses each in those two availability zones. And to connect the VPC to our office, we will be using dynamic BGP, so Border Gateway Protocol routing, and IPsec VPN tunnels. So let's start the demo. I will now switch to the browser, and I will show you first what we have in Tokyo. So when you look at the top right-hand corner of the screen, you can see that we are now in Tokyo. So basically, this is our office system. I'm using another VPC actually in Tokyo for office network. This is already created, so our office already exists. So in Tokyo, we are running two resources. There's a Windows desktop or workstation here. We will be using this later. And we have the Cisco router here. So this is a Cisco CSR or Cloud Services Router 1000V. We will be using this Cisco router from our office to create the VPN connection all the way to the VPC in Singapore. When we take a look at the EC2 console in Singapore, you can see that I'm not running any resources there. So there's nothing running, or no EC2 instances at least running in Singapore. So Singapore is where we'll be creating our remote VPC. The office is in Tokyo. So I have now switched to the VPC console in Singapore. You can see that we are in Singapore now on the top right-hand corner. And when you look at the numbers here, you can see that we are not running any VPCs. So we don't have any VPCs created yet. There are no VPN connections. There are no gateways existing. So we are starting really from scratch here. To start creating the VPC, we will be using the wizard. So I will click on this Start VPC Wizard button here. And the first question the VPC Wizard asks us is, what type of VPC would you like to create? I will quickly run through these different options here. The first option is a fully public-facing VPC. So this is a popular option if you want to, for example, host a website, a blog, a content management system, etc. Anything that is customer-facing. The second option is slightly more complicated. The second option creates a public subnet where you put your public-facing resources like web servers, and then it has a private subnet where you can, for example, host your databases. The third option is, again, slightly more complex, or let's say feature-rich. Here we have a public-facing subnet connecting your web servers to the internet, and then you have a private subnet and a hardware VPN connection back to your corporate data center. This is a quite popular option for creating complex architectures on VPC. Now today, we will be using the fourth option. So I want to create a VPC in Singapore, which is fully private, completely isolated and hidden from anyone else. I will just use the VPC to add capacity to my system. So use the elasticity, on-demand, low-cost options of the cloud to basically deliver services to my teams to create a new project when I maybe run out of capacity in my own data center. So let's make the walls of our data center in Tokyo elastic by adding a VPC in Singapore. So I will click Select, and let's start creating this VPC. The first thing we need to do is to specify the IP address block for this VPC. I will be using a B class, if you will, /16 network. So in Singapore, we will create a VPC with the network address 10.100.0.0.16. So that's a B class network. We will give it a name, Project X VPC. So let's assume that we want to create a project, but we don't want to have the upfront capital investment of hardware. And we want to get going quickly, so we want to use the cloud to create and run the resources for this project. Then we need to specify at least one subnet. So I will create the first subnet here. The first subnet that I will create will be 10.100.0.0/23. So the first 512 addresses of this complete block will be sliced out for the first subnet. So the first subnet will be starting from 10.100.0.1, going forward about 512 addresses. The first 3 addresses of these subnets are reserved for the AWS use, and the rest are for customer use. I need to specify the availability zone. So for the first subnet, I specify availability zone 1A. Later on, we will create another subnet in the second availability zone. And I will give this a name, VPC 1A. I will want DNS host names to work, and I'm fine with the default hardware tenancy. In some cases, some customers or companies have strict compliance regulations, so they may want to choose dedicated hardware tenancy. When you use dedicated hardware tenancy, it means that only your instances are running on those physical servers that you use. So you basically have dedicated servers for your instances. No other tenants' instances are running on the same physical hardware. Of course, they are completely logically isolated, even if they are multi-tenanted. So I will use the default tenancy here, which is fine. Let's click Next. Now, in the second step, we will need to define how we want to connect to this VPC. So basically, we will need to define and tell AWS what is the router that we are using in our office to connect to the cloud. So we need to give it an IP address. This is the public IP of our firewall router in our office. So let's take a look. We go back to Tokyo. We select the Cisco router that we are using for this exercise, and we find the public IP of the Cisco. It's right here. So I will copy the public IP address of our Cisco router into the clipboard, and I paste it here in the wizard. So that is the public IP of our Cisco router in our office in Tokyo. We give it a name. Let's call it our Office Gateway. We give this VPN connection a name, Office VPN. And to make my life easier, I will choose the dynamic routing using Border Gateway Protocol. If you use static, you need to define all the subnets in both ends to the routers on both sides. So you need to manually configure the subnets and routing. When you use BGP, then basically the routers will advertise all the routes and subnets available on both sides of the connection to the other side. So automatically propagating your subnets to be visible on the other side. It makes your life a lot easier. So I will choose dynamic routing. Now I click on Create VPC. Now this will take a couple of minutes. So in the meanwhile, let's switch back to the slides and continue the show. We will come back to the system once it's been created. Now let's elaborate a little bit more on VPC. Basically, using VPC, you can easily create multi-tier architectures for your applications. So in this example, for example, we have on the top, within the VPC, one subnet where we have load balancing, for example. The second subnet has web servers. Then you have database servers, application servers, and maybe bastion hosts or jump hosts and log servers in a further subnet, isolated from the rest. Now, what is the point of all this? The first point is that you will be able to firewall every single compute instance. So here we have a couple of examples of firewall rules that could be handy in this kind of multi-tier application scenario. So for example, the red color here could signify that the web servers will only accept port 80 coming from load balancers, not anything else. So we lock down the web servers and only allow whitelist the traffic that we need to allow into the web servers, and we block everything else. Subsequently, the application servers will only accept traffic in TCP port 8080 from the web servers, and everything else is locked down. And we will allow SSH to all the instances only from the bastion hosts, not from anywhere else. So this is an example of some of the best practices that you can easily implement with VPC. So that was security groups, a quick example of those. Here's an example of NACL, or Network Access Control, which is another feature of VPC. So here, in addition to the security group firewalls, we can also have network access control between the subnets. So here, we have added a NACL rule basically stating that we deny all the traffic between the web server subnet and the database server subnet. There is no reason ever for the web servers to communicate directly with the database servers, because in this application scenario, you have the application servers actually using the database servers, not the web servers. So using NACLs, or Network Access Control, you can easily add a second layer of firewall protection within your VPC systems. And all of this is, of course, documented very well in the Amazon VPC user guides, which I recommend that you read. Now, how would you connect to the internet or from the internet to your VPC public-facing systems? We have some options here. First of all, you can create public subnets and completely private subnets in your VPC. In your public subnets, you can create internet gateways. So you create an internet gateway for that subnet, and then using that internet gateway, the resources in the public subnet can access the internet. For example, they can download, for example, new packages from a repository, and of course, your external customers can then access your systems like your web servers or load balancers. With internet gateways, you open up access to your public subnet. But of course, you have still firewall rules in your security groups, etc. However, if you want to hide still your resources in your subnets, you can use NAT instances. So the second option of providing internet access is to create a NAT instance, or Network Address Translation instance. When you use the NAT instance, you don't have to allocate public IPs to your resources. With the NAT instance will translate from your internal IP addresses to its own public IP address when it's going outside. So the NAT instance does not expose your internal addresses to the outside world. Basically, it's up to you, whichever one you choose to use. Both of them work. You can, of course, allocate elastic IP addresses to the instances running in the public subnet. And you have normal control of your elastic IP addresses. You can move them between instances if you wish. Using these powerful features, you can implement DMZ, or demilitarized zone, architectures and best practices as you would in a normal data center. And then to connect your VPC, to interconnect your offices and data centers to your VPC, you can use the IPsec VPN connections, or you can use your dedicated private direct connect lines. And if you make a completely private VPC in AWS, you can then allow your VPC resources to access the internet through your office, your data center connections. This is the most secure way if you want full control of who is accessing the internet using your firewalls, your routers, your network equipment and processes in your data center to control all the access in and out of the internet. Now, let's take a look at some of the common workloads that people use when they have hybrid IT. Here we have some examples on the slide, and I will be showing you a couple here. The first one is disaster recovery, or as we like to call it, cloud on standby. Disaster recovery is something that's really, of course, useful, goes without saying, but it can be prohibitively expensive to build a disaster recovery system if you have to duplicate your data centers, have another off-site data center, duplicate all your primary systems in the secondary site, and then you actually never use your investment in the disaster recovery second site unless you have a problem in your first site. Using the cloud, it's significantly more cost efficient, easier and faster to have a disaster recovery system. So in this scenario, on the bottom you have your on-premises system. For example, you can back up your storage systems to Amazon S3 using, for example, the storage gateway or third-party products. To back up your server images and server configurations, you can use backup tools and back them up to S3 or Glacier. And you can also synchronize your databases, for example, to RDS or self-hosted database servers running in AWS. So you're backing up your storage, your servers, and your databases from your primary on-premises system to the cloud. And then if you have an oops, you have some issue, you lose your primary system or connectivity to your primary system, you can simply bring up your system in the cloud from the backups. So first, what you could do is that you could bring up servers from the server images that you have already backed up to S3. So create new servers in the cloud from the images in S3. Then you can resize your RDS or other database servers to full capacity size. So in initially you were running a very small database to save cost, only receiving the changes of the primary database, maybe asynchronously replicated. Now that you go to production with this cloud database, you may need to resize it to a larger instance to handle the capacity. If you have backed up your storage to S3, you may want to bring up a file server to actually serve the files from S3 to your users, then have more servers, connect the servers to your databases, and then using, for example, Route 53 for domain management, elastic load balancing for balancing the traffic, you can direct your users to your cloud system instead of your on-premises system. So, for example, using Route 53, you can have an automated failover. If your primary on-premises system fails, the Route 53 health checks with rules that you set can fail over the traffic to your cloud system. Or of course you can do it as a manual operation if you prefer. Doing this, basically you only pay for the resources in your disaster recovery system when you actually have a disaster. And it's trivial to practice disaster recovery using the cloud, which is something that is very difficult to do when you have physical disaster recovery second sites. The next method how people quite often use VPC is for development and testing. So say that you have your corporate systems there. You want to be able to innovate. You need to be able to experiment. So you need to be able to have the cost of failure approaching zero. The cost of experimentation has to be very low. So that's where the cloud is really handy. So for example, you could create a new development VPC for your new project. And then you have test VPCs where your testers are verifying what the developers are doing. So you have your first application coming up in the development VPC. Using, for example, CloudFormation, you can create a template that describes the new developed system. And you can simply copy-paste and apply more copies, identical copies of the application in your testing systems. This assures that you have repeatable, reproducible, automatic testing here. So for example, you can have functional, integration, capacity and stability testing all being executed simultaneously in the cloud with identical configurations from the original in development, guaranteed by CloudFormation templates. Another team may want to use, for example, Elastic Beanstalk simply to focus on the application development and let Elastic Beanstalk handle creating the infrastructure for the application. So then using Beanstalk, you can easily replicate and deploy more instances of the application into more environments in the testing VPC. Another team may want to use OpsWorks. And again, you can copy and replicate the OpsWorks development system into your testing environments. No matter what lifecycle management tool you use, ultimately it's trivial then simply to copy and back up all your application templates and descriptions into S3 for archival. And later on, when you need to create another environment and instance of your application, you can simply retrieve it from S3, click, bang, and deploy. Big data analytics is another popular way of using VPC. One of the reasons is that many companies want to now use data to have data-driven business decisions, but it can be prohibitively expensive to build big data systems in your on-premises systems. The initial capital investment may be quite large, and companies may not know initially what big data systems, solutions, or building blocks they want to use, so they need to experiment. So using VPC, this is quite easy and very, very cost efficient and fast. So for example, you may have your production systems in your corporate network. Those are your servers producing the data. Then you can create a VPC. You can upload the data to Amazon S3 for durable, cost-efficient storage. You can use Elastic MapReduce for Hadoop analytics using Hive or Peak, etc. Maybe clean up the data and then upload it to a data warehouse like AWS Redshift. And then you can run business intelligence analytics platforms like Jaspersoft, MicroStrategy, etc. on EC2. And the AWS Marketplace is a really handy place to discover all kind of different business solutions for your different analytics and other big data needs. Now, let's get back to our demo system and let's take a look how things are going there. So in the second step of the demo, we basically left the system creating the VPC in Singapore. Now we will log in again, take a look how it's doing, and then we need to create the IPsec VPN tunnel between our Office system and the newly created VPC. And if everything goes fine and we interconnect our Office and the VPC, we need to deploy some stuff into the VPC. So in this case, we will be deploying a content management system within the VPC in Singapore. So this is the system now we are continuing to build. So on the left, we have our Office in Tokyo. We have the Windows workstation. We will be using it soon. We have the Cisco router. Then we have the VPC in Singapore with 2 availability zones. We have created 1 subnet so far. And ultimately, we want to deploy a CMS using Drupal into this VPC. So let's get back to the demo system now. Here we are. Now the VPC console tells us that the VPC has been successfully created. Let's click on OK, and let's investigate what we have now in Singapore. We have a new VPC. It's called Project X VPC, and it's available. So the VPC itself is available. It has the B-class network address, 10.100.0.0/16. Let's take a look at the subnets. We initially created 1 subnet here, and you can see that it's available. The address of this subnet is 10.100.0.0/23, so roughly 512 addresses, and it's in availability zone 1A. Let's create another subnet so that we can fully utilize both availability zones in Singapore for redundancy. Let's give it a name, VPC 1B. We create it within this VPC, and we select the second availability zone. And we need to give it an address space, 10.100.2.0/23. So these are the subsequent next block of 512 IP addresses. I click on Create, and in a few seconds we will have a second subnet available here. So this is how easy it is to create subnets within your VPC. So after this, we should have 2 subnets, both with 512 addresses. The first one in availability zone 1A, here, and the second one is now created with another IP address block, and it's in availability zone 1B. Okay, that's good. Now we have a subnet in both availability zones. That's fine. Let's continue our investigation. Let's take a look at the routing tables. So we have a routing table that was created automatically by the system when we created the VPC. But as you can see, currently the routing table doesn't have too much. There's only one default route here, and this is the local address space. So 10.100.0.0/16 is the local address space within the VPC. You can see that it's named local and it's active. So basically this is a default route allowing the different subnets within the VPC to talk to each other. And that's it. There's no other route. So pay attention to this. For example, this routing table does not know anything about our Office in Tokyo. We have not connected to Tokyo yet. The Internet Gateways tab is where you would have Internet Gateways if you make a public-facing VPC. This one is not public-facing, so we don't have any Internet Gateways. We could easily create one here and turn this subnet into a public-facing subnet. I want to keep it private, so I will not create one. If you want, you can specify DHCP options. So when your instances get DHCP IP addresses, you can populate the DHCP options with some of your own tags if you want. This is a handy way of passing information to your instances. You can use elastic IPs in a familiar way within VPC if you want. And using the peering connections, you can also interconnect multiple VPCs within the same region. So if you make multiple VPCs, you may want to allow direct network access under your control between your own VPCs in the same region. For example, from development to testing environments. So this is where you would create peering connections between your VPCs in the same region. And if you want to have subnet level stateless firewall control, you would use the NACL or network echo. Currently, I have the default rules here. I will show to you briefly here. So the default rules are to allow all the traffic between the subnets here. You can make them more restrictive if you want to use this second level of firewall control. They are stateless firewall rules between your subnets here. The security groups are the familiar ones that you're used to in EC2 Classic, with the exception that now you can also control outgoing traffic. Now that's all fine, but we haven't connected anything yet. So we have our office system in Tokyo, we have the VPC in Singapore, now it's time to connect the two. That's why we have the customer gateways. So when we created the VPC, I basically told AWS what is my Cisco router's public IP address. That's all it knows currently. That's here. You can see the public IP of the Cisco router here, but nothing is connected. The AWS Cloud has also configured the VPN concentrator on the Amazon side. So this is the Amazon side of the VPN connection, ready for the connection. So this is waiting to be connected to. The virtual private gateway is the Amazon side of the VPN connection where we will be connecting to. But we haven't connected yet. So when we go to the final tab here, which is the VPN connections screen, we can see that we have a VPN connection, but it's actually not up yet. So here you can see that every VPN connection will have two tunnels for redundancy, but the status of our tunnels is down. IPsec is down for both tunnels. That's because we haven't configured anything. How do we know? Well, let's go to our Cisco router. Let's look into the Cisco router now. So the Cisco router is here. That's the public IP. I will copy it to the clipboard. So it's 135.26. Here it is. I will SSH from my laptop now to the Cisco router in our office. Now we are in our Cisco router. Let's see show version. You can briefly see here that this is a Cisco iOS machine. It's a CSR 1000V router. But when I execute show running configuration on this Cisco router, you can see that there's nothing much here. There was an IP address there, certificate, username to log into the system that we used just now, a couple of interfaces to connect to, and that's it. So basically, this Cisco router has empty configurations. It's vanilla out of the box, if you will. So we need to change that. Normally, it's rather difficult to create VPN connections. So let's see if Amazon can make it any easier for us. So we want to create a VPN tunnel from our Cisco router to this VPC. There's a handy button here, download configuration. So I click on this button, and we can ask the AWS Cloud to provide example configurations for our router in our office. So we support a few different manufacturers here. If you happen to have routers, firewalls from any of these manufacturers, then we have specific configurations that we can generate for those. There's also a generic router option that you can use to easily modify to your particular router then. So if your router manufacturer is not listed here, then choose the generic one. We are using Cisco, so I choose this Cisco option. I click on download, and now the AWS Cloud creates VPN IPsec connections that are specific for Cisco router. And here they are. My browser downloaded them here. So I open the text file, and this is the configuration that was auto-generated by AWS. You can see it here, Amazon Web Services Virtual Private Cloud. So this is a Cisco configuration. Now we need to do one change here. We need to change the Cisco configuration from the public IP to the private IP. The Cisco router in this case has two IP addresses, a private IP and a public IP. But its self IP, it prefers to have a private IP in this case. So I need to make one simple change here. I need to find all these public IPs using the find and replace function of the text editor. I replace the public IP with the private IP. So we need to find the private IP of the Cisco router here. 1096.24.236. So we replace public with private, and I click on all. There. So now using the text editor, I replaced all the public IPs of the Cisco router to its private IP. Now I select all the text, I copy it to the clipboard, and then we go back to our Cisco router here. And now let's apply the configurations. Let's configure our own router in our office in Tokyo. We need to enable configuration, configure the system from the terminal, and now we are ready to paste the configuration. So I Apple V or Control V, and I paste the configurations that we got from AWS into the Cisco router directly. So after a few seconds, the paste is done. You can see that the VPN configurations are going there. There you go. Now we just simply execute end to tell the router that we are done with the configuration, and then we jump back. Now we have configured the Cisco router. Let's go back to the VPC console and pay attention here. Currently the channels are down. I refresh the page. This will take a few seconds. So basically what we have done is that we have one route up now. You can see one channel is up with one BGP route. So we pasted the configuration that AWS gave us into the Cisco router configuration in our office in Tokyo. And we applied the configuration. Then our Cisco router immediately started handshaking with the AWS cloud in Singapore. Now refresh the page again. Let's see if we get the second. Yes, there we go. So now we have both VPN tunnels up. We have two VPN tunnels up from our office in Tokyo to our VPC in Singapore, and we have a BGP route also propagated. What does it mean? Let's go back to the route table. So remember earlier we had only one route, now there's a second route. So basically now in the VPC, any local address is active by default. Now there's a second route. Any other IP address, what any other? Local addresses are routed locally within the VPC. Any other IP address is sent to the gateway back to our office. So if you don't talk locally within the VPC, if the destination of the IP packet is any other address like our office, it will be sent to our office gateway. Now that's fine. Does it work? Let's see. To finish off the demo, we should have now a VPN connection from our office to the VPC in Singapore. Let's deploy a workload in Singapore. So this is EC2 in Singapore. This is where we have the VPC. We are not running any resources here. Let's launch an EC2 instance. Let's go to the AWS Marketplace. We want Drupal. So I search for Drupal in the Marketplace. I choose the first option, which is Drupal powered by Bitnami. It's an appliance made by Bitnami that has the Drupal CMS. I choose the general purpose M1 small instance type. That's fine for us. But now, instead of deploying Drupal into EC2 Classic, I will deploy it within our VPC. I can choose the subnet from 1A or 1B, doesn't matter, I choose 1A. And I don't need to give it an IP address, a public IP, because this is a private VPC. So we can keep this fully private. So I will want to deploy Drupal within our VPC in Singapore. I don't need any additional storage, but let's give this instance a name Drupal. And then for the security group, because our VPC is fully private, I can basically add a simple rule to allow all traffic to the Drupal system from our office. And our office is at 10.96.24.0/21. This is our office address space in Tokyo. So basically now the Drupal instance will allow any traffic from our office 10.96.24.0 to itself. So let's launch this Drupal instance. I select my key and click on Launch. So now we have created a VPC, we have configured the Cisco router. You could see that 2 VPN tunnels came up. There was a route that was propagated by BGP, sending all the traffic that's not local to the VPC back to our office through the gateway. And now we also deployed a Drupal instance into the VPC in Singapore. So now we can see that we have an instance running in Singapore. Well, it's booting up now. It's probably not running yet. It's booting. It's called Drupal. And we can see here that it's actually running within the VPC. And what is the IP address? The IP address is 10.100.0.183. 10.100.0.183. Let's log into our office now. In our office, I have a Windows workstation. So you can see its address is 10.96.28.49. So this is our office in Tokyo. I have a Windows machine there, and I have a remote desktop open, which has closed, so I will open it again. Give me a second. We reconnect back to our Windows machine in Tokyo. There we go. So this is the Windows machine in Tokyo. Its own IP address is 10.96.28.49. And in the routing table of this Windows machine, I have made a route that to go to 10.100.0.0, which is the VPC address space, all the packets should be sent to gateway 10.96.24.236. What is this? This is the Cisco router. 236 is the internal IP of the Cisco router. So basically this Cisco router is the local gateway for this Windows workstation in Tokyo. So if the Windows workstation wants to talk to the VPC in Singapore, it will send the packets to the Cisco router. The Cisco router has the VPN connection, which is up. So it should forward the packet to the VPC in Singapore. So if the Windows machine wants to talk to the Drupal instance in Singapore VPC, it will send the packet to the Cisco router. The Cisco router will use the VPN connections, tunnel to the VPC in Singapore, and then finally reach the Drupal instance within the VPC. Now let's see. The Drupal instance is 10.100.0.183. Let's try to ping it. Ping 10.100.0.183. And it works. And pay attention to the ping time. It's roughly 77 milliseconds. So this is roughly the average round-trip latency between Singapore and Tokyo. Now to finish off the demo, we are able to ping the Drupal instance. Are we able to use it? So this is our office in Tokyo. Let's try to access with the browser. HTTP 10.100.0.183. There we go. Congratulations, we are now running Bitnami Drupal in the cloud. So here we have an office workstation in Tokyo. using the Cisco router and the VPN connections to connect to the VPC in Singapore. And we are using this Drupal resource that we deployed to the VPC just now together. So basically we have now hybrid IT architectures at work. Hybrid data centers between our office in Tokyo and VPC in Singapore. That was the demo. I really hope that you enjoyed it. Thank you very much. I went a few minutes over time, but we still have time for one important thing. Let's have a poll. So now we will be starting a poll because we really want to know what you want to see next. So let's start the poll now. Okay, thank you very much everybody who voted. Your feedback is super important to us because it will let us know that we can deliver systems and services and solutions and webinars that are meaningful to you. So roughly just to let you know that the winner of this poll is designing scalable, available, resilient systems. 39% of the viewers voted for that one. Excellent. Thank you so much for your help letting us iterate further. And at the end of the webinar, we still have a survey. Please fill in that one as well. It lets us know additional information. Now we will be closing the webinar.